Hello, everybody. I hope you're doing well. So in the previous video, we have kind of pre-processed our pandas data frame in a naive way, and we're going to essentially move on to statistical analysis. So we're going to make our imports. So we're going to use pandas, matplotlib, and seaborn, and you'll see how these libraries come in. So we know pandas is a data manipulation library. As a teaser, matplotlib and seaborn are essentially visualization libraries that are commonly used in Python. So you'll see them in action. So one thing that's important to understand is the idea of a distribution, right? So how is your data distributed? And one of the most popular distributions, like in statistics, is normal distribution. So a normal distribution appears in a lot of places. So for example, you can think about blood pressure, IQ, height, weight, etc. These things generally follow a normal distribution, and it's represented by what's called a Gaussian curve. And it's shown in this graphic below, right? So normal distributions tend to mimic phenomena very well, and you see them pretty much everywhere, right? So this is what the graphic entails, right? So for a normal distribution, we have a center called the mean and a standard deviation, and we have a measure called a standard deviation, which measures on average how far is your data spread out, right? Like what's the spread and average of your data. So if you're at the center, which is the mean, and you're one standard deviation to the left and right, 68.27% of your data is within that region. If you are two standard deviations to the left and the right of this center, that would be 95% of your data approximately is contained within, this region here. So the purple and the, pinkish region. If you're within three standard deviations, so three to the left and the right of the mean, then approximately 99.7% of your data is contained. So the green, the purple, and the pinkish region, right? So this is what we call the 68, 95, 99.7% rule, otherwise known as the empirical rule. So let's take a look and see this in action, right? So a normal distribution is important because as a data scientist, we want to be able to interpret our data given by our environment. And of course, we don't want to have too much bias that skews our analysis. We want to just capture the environment and from there conduct our own analysis, right? So one theorem that's very, very powerful is something called the central limit theorem, right? So the central limit theorem goes like this. So the sample sum slash average will approach a normal distribution as the sample size becomes large. So there are mathematical proofs for this. So as your sample size increases, when you take the mean slash average, that distribution of the mean will approach a normal distribution. But I think this graphic is really all you need to understand. So let's say you roll a die, right? And this is the distribution of how many times you get 1, 2, 3, 4, 5, and 6. Imagine if you had, two die rolls and we kind of take the sum of the die rolls, right? Do it for 3 die rolls, 4 die rolls, 5 die rolls, and 6 die rolls. You see how this curve becomes like kind of relatively flat and this curve is starting to become more like this curve right here, this bell curve. This is the power of the central limit theorem, right? So the larger your sample size, the more likely that, your distribution of the mean, right, will approach a normal distribution. Now, I know this graphic might sound a little bit confusing, but you'll see this in action in code, which is interesting. So that's what we're going to do in the next video. So we're going to conduct a brief demo of the central limit theorem so that you gain a greater appreciation and understanding of it. But till then, see you in the next video.